is the probability of event B occurring, knowing that event A has already occurred. Okay, so this is going to kind of go back to some of the things that we dealt with yesterday with independent, dependent events, because there are two things happening here. The notation for conditional probability is probability of event B, and then it's a straight up and down bar, and then the A. So that's probability of event B happening given A already happened. So whatever's listed first is what you're trying to find probability of happening. After the straight up and down bar is what has already happened. Okay, so what conditional probability usually does is it trims down what we're looking at, okay, from the entire student population to just juniors or something like that. So that's what conditional probability does. Read that as the probability of B given A. That's how that's read, that notation. It's probability of B given A. The formula for doing that, probability of B given A, is you take the probability of A and B happening and divided by the probability that A already happened. The probability of A and B happening divided by the probability that A already happened. So let's look at some ways of doing that. There's a couple of different ways to go about doing this. One of the ways is to take that formula and do that every time. And sometimes that's an always going to work kind of thing. But sometimes we can make it simpler by just kind of mentally cutting out the things that are already happening for us. So number one says Mitchell drew a card from a standard deck of playing cards, so 52 card deck. What's the probability that he drew a queen given that the card was red? So if we do it with the formula, we need the probability of drawing a event A is that it's a red card. So how many red cards are there? 26 out of 52. That's one event. The other event is that it's a queen. How many queens are in the deck? 4 out of 52, right? And then we divide by how many, by the probability of getting a red. So that'd be 26 out of 52 that we're dividing by. On this one, see what happens here is the 26 out of 52 cancels each other out. If we think about this in terms of just narrowing down, if we think, okay, given that the card was red, we know how many red queens are there? 2, and out of how many red cards? 26, which is the same as 4 out of 52, or 1 out of 13. That's what it reduces down to. So with the formula, we get the same answer, but if we think about it in terms of just narrowing it down, hey, given that it's a red card, hey, that cuts it down to the 26 red cards that there are. And then we're looking for how many queens are in the red cards. There's 2 queens that are in the red cards. So that's the 2 out of 26 way of doing that to get the 1 over 13. So both ways are going to get you the same answer. One way takes, a little bit more operation going on there, but it's the same answer. Number 2, the numbers 1 to 100 is randomly selected. What's the probability that it is a perfect square? Number from 1 to 100 is selected, given that it's an odd number. All right. Perfect squares. What numbers are perfect squares? Maybe we need to know that before we go too far. And how many there are in that. So let's get our perfect squares from 1 to 100. 1, 4, 9,
16, 25, 36, 49, 64, 81, 100.
And 1. All right, so there are perfect squares from 1 to 100. So we know those. Always helpful to have that information. Probability that it's a perfect square given that it's an odd number. Okay, so How many perfect squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? How many of those are odd? How many? Four of them? Probability that it's a perfect square given that it's an odd number. Okay, wait, we're not doing, okay. Let's look at technology. Just getting going. What's our given in this problem? Odd number. So that narrows it down to how many numbers from 1 to 100 are odd? 50 of them, right? Okay, so there are let's try it. Okay, come on. Okay, all right. Let's try again here. This will work. We'll just do it. Here we go. All right. So there are 50 odd numbers. So we could narrow it down to 50 numbers. And then there are how many odd ones in the list of perfect squares? Y'all said 5 of them. Let me not in the cards first. We work today. So 5 out of 50 would be how much? 1 out of 10, right? So that's doing it by narrowing it down beforehand. So we're narrowing it down beforehand. You know, we know there's 50 odd numbers, and then how many? And then there are perfect squares. There were how many odds? 1, 2, 5. So 5 out of 50 is 1 out of 10, right? That's one way of doing it. Okay, I think that's maybe the more intuitive way of doing it. You could also do what's probability of picking an odd number? Well, it's 50 out of 100. What's the probability of picking a perfect square? 10 out of 100, right? Divided by 50 out of 100. Those cancel each other out, and hey, we got 10 out of 100, which is still 110. So the formula gets you the same answer as kind of just doing it logically. I kind of like doing them logically for the simpler problems like this. You know, they don't get too much more complicated than this. But let's look at number 3 and take a little, maybe a different approach. I'm not sure. There are 62 people that take a yoga class, 48 people that take a spinning class at the gym, 15 people that take yoga and also take spinning. If a person from these groups is selected at random, find the probability that he or she takes a yoga class if you know that they take a spinning class. Okay, so how many people take? So we're looking for probability that they take a yoga class, given that what they take spinning. And spinning is SPI. Hopefully, don't take a sipping glass. I'm about to give it. No, it's not. We have somewhere we need to be by the end of next week, and I want to be there without overloading you on any given day. All right. So one of the ways of doing this, one skill that's good here is a Venn diagram. Y'all remember doing those, or have you ever done those? The Venn diagrams, you remember the circles that overlap, those things? If you have one circle that is a yoga circle and the other one is a spin circle, let's fill in that Venn diagram and see how we could use it to help us here. All right. So 62 people that take a yoga class, 48 people that take spinning class, 15 that take both. Where's the 15 go?
In the overlap.
In the overlap. So 15 goes in here. And so if there's 62 total that take yoga, 15 that take both, how many just take yoga? 47, yeah. How many just take spinning?
48.
No, 48 people at the gym take spinning, we go 15. There are 15 people at our gym that take both of them. So there'd be 33 that just take spinning only, that don't take yoga. All right. So now find the probability that this person takes yoga given that they take spinning class. So that would be, how many people take yoga that also take spinning? 15. How many take spinning? How many take spinning? Let's try again. 48 take spinning. 15 of those people are taking spinning and yoga, but they take spinning. 15 out of 48 will reduce because they're both divisible by 3. 5 over 16, right? Could that have been done without the Venn diagram? Absolutely. Is the Venn diagram a requirement to do that? No. I just think it's a good skill to have to be able to fill in these Venn diagrams. It can make you make problems a little simpler to deal with there. Look at number 4. We'll do a Venn diagram for it too. The numbers are pretty small. 30 students in Mr. Smith's math class. 13 are athletes. 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that student is in band if it is known that they're not an athlete. So there's some knots in there. So 2 circles, sports and band. All right. 13 are athletes, 9 are in band. 3 of the athletes are also in band. Okay. 30 students in the class. Let's try to fill in our Venn diagram here. How many people are athletes? 13 total are athletes. How many of those overlap? 3. So we know there's a 3 in the middle there, right? So how many are in sports only? 10. How many are in band only? 6, right? Total of 9 in the band. Now, that doesn't add up to be 30, right? Where are the rest of them? Not in any of those circles. Like they would be out here, the people that aren't involved in sports band. They may do other things, but they're not involved in these. So what's that? 22. So there's 8 people that are outside of those circles somewhere. Okay. So, just so we know that, hey, that's 30 people total, right? Did I do that math right? No, I did not. That's 9. It should be 11. Sorry, I can't subtract. Do a lot of other things. Subtraction. Got me. All right. So, wants to know, find the probability that the student is in band given they are not an athlete. So, not athlete. Remember our notation we talked about? The little squiggle, tilde. Athlete means not an athlete. So, how many are not playing a sport?
No.
17, because we got the 11 that aren't part of band or sports, and then the 6 people that are just in the band that don't play a sport. So there's 17 total. And then how many people are in the band? 6 of those. 6 out of 17 does not reduce 17 prime. So there's a Venn diagram. That 11 wasn't part of the Venn diagram, but it was. So we just need to know that, hey, that 11 people didn't do either of those 2 things. So you got to be careful of that. Okay. So Venn diagrams really can help you on problems like this, especially if they start throwing like 3 different things in there and you got a 3-circle Venn diagram. Sometimes that could be helpful. Another helpful thing in doing probabilities are these 2-way tables. A table that records the data that pertains to 2 different categories. So this is kind of like a Venn diagram, but in a table form, and it a lot of times is organized a lot better really can make it easy to pull things out of. It says, in this example, the table shows the results of a poll for 50 randomly selected students that were asked whether they prefer to watch hockey or football. Find each probability. Okay, so probability for part A is asking for probability that they prefer football given that they're a girl. Okay, so this is one of those things where you think about logically how many, you're not going to do that formula. Logically, how many girls are there? 22 girls total. How many prefer football? 6. That's an easy thing to do. 3 out of 11. B part, probability that it's a boy given they prefer hockey. How many people prefer hockey? 26, right? 10 out of 26 that prefer hockey, or boys that prefer hockey. So the given is, do what now? How is it 20? It's probability that it's a boy given that they prefer hockey. So given that they prefer hockey means the people that prefer hockey. The given is the total. Whatever the given is the total. Over here on A, the given was that it's a girl, so we total up how many girls there were. Here, the given is hockey, so we total up how many people like hockey. So the given is going to be your total out of, how many people out of that, okay? The probability, the first thing listed is going to be your top number. Bottom number is going to be your total for that, okay? So 10 boys prefer hockey, and there was 26 people that prefer hockey, so that'd be 5 out of 13. All right. All right. Look her over there. All right. Got another table here. Find some probabilities. And so they write some of these in the given notation with the bar in the middle. Some of them they use other words that mean the same thing. Okay. So the table shows results for a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. 6th, 7th, and 8th graders, and then we need to find these probabilities based on that. So probability, a 7th grader who takes French. Okay, what's the given here? Is there a given here? Probability, it's a 7th grader who takes French. Well, it doesn't say only how many probability of being a 7th grader in French class. It's a 7th grader who takes French. How many 7th graders take French in their chart? 25 of them. How many people are in our chart? 150. And reduce that 6 quarters in $1.50. So that'd be 1 out of 6. Probability of picking a 7th grader who takes French is 1 out of 6. If we pick from that 150, that's what the probability of picking somebody that's in 7th grade that takes French is. B part does have a given. It's got the bar in the middle of it. So that we know that we're going to narrow this down some. It says probability of picking an 8th grader given that they take Spanish. That's what the bar means, given that they take Spanish. So that means what part of this chart is the total? Just the Spanish, everybody that's in Spanish. Okay, so total 23, 12, and 33. 23 and 12 and 33 would be 45 and 68. Probability of an 8th grader. How many 8th graders are in that group? 33. And that does not reduce. 33, 3 and 11. 68 doesn't get any of those. C part, probability that they take French. So we're picking someone who takes French, given that they're in the 6th grade. So how do we find our bottom number here for this one? No. 6th graders. Remember, you're given what's after the bar is going to be your total. Okay, so we're given that there's sixth graders. So we're going to total how many sixth graders did we have? 52, 42. Can't add either. And then 19 of those took French, and 19's prime, so I know that's not what I would do. D part, probability of picking a seventh grader given that they take French. So our bottom number is going to be the total of which part? The French column. So 19, 25, and 38. 82. Is that right? 15. Yeah. And then probability of seventh graders. How many seventh graders in that group? 25. And that 5 doesn't go into 82, so that doesn't reduce. When you're given, if you have a given, that's going to be narrowing it down. Number 6, got another table, different situation. So the table results are a poll of randomly selected juniors and seniors who were asked if they attended prom. And we got juniors column, senior column, yes and no rows. Probability that is picking a junior that did not attend prom. Okay, probability of picking a junior out of it doesn't have the given, so this is a out of the whole group kind of thing. So, how many people were polled? 200. Add all those up. How many juniors did not go to prom? 56, and we need to reduce that. 8 goes into 200 25 times, because that's how many quarters are in $2. 25 times 8 goes in 56 7. B part says probability that did not attend prom given that they're a senior. So what's our total for this one? Seniors. So 97 plus 19, 116. And then how many did not attend prom? 19 of them. And that doesn't reduce 19's primes. C part, probability of picking a junior given that they attended prom. So our total would be the folks that attended prom. So 28 and 97 added together. The 125. And picking juniors out of that's 28. And that doesn't reduce 28. So the charts and tables really make that a lot easier. All right, let's talk about frequencies and frequency tables and how that can be used to build some probabilities out of that. So joint relative frequencies that are the values in each category divided by the total number of values. So joint relative frequencies are the values of each category divided by the total number of values. So it's really it's kind of like the probability of that individual piece. Okay. The marginal relative frequencies found by totaling each row and column. Okay, so what we've got here on the left is a chart of some data, and on the right we're going to make a frequency chart out of that. Okay, so the table below shows the number of first class and coach class passengers on a plane who check one bag, two bags, or no bags. Find the joint relative and marginal relative frequencies. Then find each probability. Okay, so we're going to build this table of the frequencies and then use that to help us do these probability problems. Okay, so notice there's exactly, you got 3 and 3. This part, those two pieces relate directly to this chart, those two columns. This part and this part, those are what we're going to calculate up, after we've found those relative frequencies. Okay, so how many passengers total are there? So we add up 16 plus 12 plus 2 plus 18 plus 60 plus 52. So total all of those up to get how many passengers there are. It'd be 160, so 160 total. All right, so we're going to use that, and we're going to convert to decimals here. So for first class 2 bags, be 16 divided by 160. Should be 0.1, right? So we're going to put 0.1 right there. And then I'm just going to go down that column. 1 bag would be 12 divided by 160. 0.75. And then 2 divided by 160. 0.0125. So those are the joint relative frequencies for first class passengers. Okay. Let's find the joint relative frequencies for coach class passengers. So we got 52 divided by 160. 0.325. 60 over 160. 0.375. And 18 divided by 160. 0.1125. So those are the joint relative frequencies for the coach class passengers. Now, the marginal relative frequencies are going to be the total of each column, goes right underneath it, and then the total of each row goes off to the side there. So we're going to find those marginal probabilities, or excuse me, relative frequencies. Let's see where I'm going here with that. So adding those together, so that'd be 0.425. 0.075 plus 0.375. 0.45. And then 0.125. 0.1125. And if I total up the columns, be 550, either one, so it'd be 1875. Is that right? And then total up that column, 81.25. That bottom corner there, that's how you can tell if you've done it right. That bottom right corner. Because what do all probabilities add up to be? 1. So 0.1875 plus 0.8125 adds to be 1. If you add 0.2425, 0.45, and 0.125, you add those up together, it's going to be 1. If you add all your frequencies up in the totals, and they don't, the column doesn't add up to be 1, and the bottom row doesn't add up to be 1, something's wrong. So that's how you can know if you did it right or not. So we know that this should add up to be 1 right there. If it doesn't, something's wrong. That's how you know you got one of your relative frequencies wrong. All right, so let's try to use this to help us in finding that probability. So probability that a coach class passenger, a probability of picking a coach class passenger that did not check any bags. So how, is that directly in our chart, or is it something we'll have to put together? A coach class passenger that did not check a bag. Where's our coach class passenger? Look at the frequency chart we filled out. There's our probability right there of a coach class passenger. So that's column right here is coach class people. Right there is 0 bags. They did not check a bag. That's 0 bags. So that right there is the probability, 0.1125. You could you could convert that to 11.25%. I'd take it either way. I'm not, you don't have to convert to a percent. But if you put 0.1125, that's right. If you put 11.25%, don't put 0.1125%. That's not the same thing. Okay, so it's either leave it as a decimal or convert to a percent. Either way is fine with me. All right. So that one is directly from our chart. And we could have found that using the way we've been doing it, where we took 18 divided by the 160. That's how we got that decimal anyway, right? So the chart really just has your decimals already done for you. B part says a first-class passenger that checked at least one bag. Okay, so at least one. What's that mean? One or two. For our chart, we've only got data for one bag or two bags. We don't know about people that check more than that. If you check more than that, you have a really stressful trip to the airport because you got to find all those when they come off the plane. That's not fun. All right, so at least one bag. So we're dealing with a first-class passenger that checked at least one bag. So that would be this probability and that probability, right? So we're going to add those together. So 0.1 plus 0.075, 0.175, or 17.5%. Of the people do that. C part says a coach class person is picked given that they checked one bag. So given that they checked one bag, a coach class person is picked. What's the probability of people checking one bag? 0.45. That total over there on the right side, 0.45 is the probability of somebody checking one bag. We want probability picking a coach class person from that, right? Yeah. So that'd be 0.375 out of the 0.45. 0.375 divided by 0.45. 0.83 repeating, which is 83.3%. So again, either the decimal or the percentage. I don't care which one. I'm going to be too picky about that. Be able to if it's a multiple choice situation, be able to recognize whichever one's there. D part says probability that they checked two bags given that they were first class. So we got to narrow down to first class. So what's our total for first class? 0.1875. And then probability of them checking two bags would be 0.1. We're going to do that calculation. 0.1 divided by 0.1875. Or 53.3%. Either of those will be a fine answer for me. Relative frequency charts are nice because probabilities are already in there, but they're not what I would say is necessary to be able to find. We could have done all of those probabilities just from the original chart, but sometimes you don't get the original data, you only get the percentages or the probabilities out of that, a frequency chart. Well, if some of you guys will probably end up taking statistics here, and some of the data that we get there is just a frequency chart. It's not the original data. So you got to be able to work with either one. So this is kind of just an introduction of being able to work with the frequency chart out of that. So it's a really pretty easy thing here.